Dr. Vijay Lakshmi is working as a professor in the Department of ECE, Anna University, Chennai. She has more than 17 years of experience in teaching. She has published more than 90 papers in international and national journals and conferences. She has organized more than 10 workshops and has attended more than 40 workshops and seminars. She has guided more than 100 projects in both UG and PG level. She is supervising 14 research scholars. She has established an AICTE sponsored MODROB project for VLSI Lab. She has an endowment award for the top rank holder in PG degree and has 4 cash awards for producing 100% of result in Anna University curriculum. She is a life member in various professional bodies like ISTE and IETE. She has specialized in mobile communication, microprocessor and microcontroller, digital system, computer networking, and neural networks.
Welcome to UGC lecture series BSc Electronics Honors Electronics Practicals 9 8085 Microprocessor Programming. In today's episode, we will discuss about multiplication of two 8-bit numbers. So, how to multiply two 8-bit numbers? Actually, in 8085 there is no multiplication instruction. So, we couldn't directly multiply the two numbers. So, we have to use some logic how to generate the multiplicated value. So, here we are using the consecutive addition concept for generating the multiplication. That is, if you want to multiply 5 into 2 means 5 is 2 times added or 2 is 5 times added. Based on your input you can add it, right. Suppose 7 into 5 means 7 5 times added, then you get 35. The same concept will be discussed today with carry and without carry. That is, after multiplying the two 8-bit numbers, whether any carry is occur or without carry. Actually 8-bit by 8-bit. Suppose I want to add number 07 into 05. These two are two 8-bit numbers. So, we couldn't directly multiply, which is not available in 8085. In case of 8086 or advanced processor, you can directly use mul AB. The two values will be multiplied and result is stored in the accumulator. But that facility is not in 8085. So, we have to use the consecutive addition. 07 is 5 times added. So, by adding this kind you can generate it. That is how we are adding, means first 07 is added with the 07, then that resultant, suppose in decimal I will explain for easy understanding. So, 7 plus 7 14, right. So, 14 again added with that, then it become 21, then again added with that 28, then again added with that. So, 35 you get the answer, right. What is the logic of this? So, one number should be initialized in the accumulator, the another number should be initialized in the counter. So, for every addition the counter is decreased. So, by decreasing that 5 times is over. So, after that we can terminate the loop. Suppose if you are taking the same example 7 into 5, so 35. So, 35 is not a actual answer, right. This is a hexadecimal number. So, the 35 should be converted into hexadecimal. So, 2 times 32 remaining is 3. So, the answer is 23. Okay. Now, we will write the program how to multiply 07 into 05. So, I have to take 2 registers to initialize the value. So, I will take B and C register, MVI B comma 07H. So, I know the value, so directly I load it. Then MVI C comma 05H. Okay. So, the initialization process is over. Then what I have to do? I have to add either 7 in 5 times or 5 in 7 times. So, I take 7 in 5 times. which will reduce the loop also. So, before adding, I have to ensure that the accumulator is cleared or not. So, for that I am clearing the accumulator. Okay. Now, accumulator value is cleared. I started to add the numbers. Add B, which represents 0 0 plus 0 7, right. That time the counter value was decreased, which is 0 5. After that I have to decrease the value DCR C. So, now it become 0 4. So, the process to be repeated till it reach the value of 0. So, if it is not 0 means I have to continuously add the values, right. So, now what is the accumulator value, which is 0 7. So, the 0 7 is added with the B. The B value is fixed only, which is 0 7. So, now the value is 1 4. Okay. I will take in decimal, later we will convert into the hexadecimal. So, 14, now the counter value is decreased as 0 3, right. So, 3 is not a 0. So, again add with the, go to the instruction add B. So, the previous resultant value, accumulator value is 14. Now, the current value B value 0 7 is added. Now, you get the value as 21. So, after 21 you have to decrease the counter, which is 0 2. 0 2 is not a 0. So, again move to this instruction here. So, add B. Add B is 0 7 with the previous accumulator value 21. So, now the result is 28. Now, move to the next instruction, which is DCR C. So, which is reduced to 0 1. It is not a 0. So, again we have to use add B instruction. Add, the accumulator value is 28, B register value 0 7 is added, the result is 35. Okay. So, then we are taking the next instruction, which is DCR C. In the DCR C, it will reduce the value as 0 0. Now, it will check it, it reaches the 0. So, it will exit from the loop, it not rotating the loop, right. So, once it exit from the loop means it represents the 0 7 is added 5 times, or simply you can say the 7 is multiplied with 5. What is the next one? We have to store the result. So, to store the result, which is in the accumulator 8-bit content, so you take STA 4300H. So, now the 35 which is in accumulator is moved to the location 4300H. So, this is a way how to write 8-bit multiplication. Now, we will convert the program into opcode. I will start the address as 4200. Okay. In 4200, first I have to write the opcode for MVI B. This is a 2-byte instruction. So, MVI B, which is 06, then give the operand 07. So, leave the 2 address, then take the next address. MVI C opcode is 0E, the value is 05, then leave the 2 address, which is a 2-byte instruction. So, next one is 04, MVI A, which is 3E00. Okay. Then 4206. Now, you have to enter opcode for add B, which is 80. This is a single byte instruction. Then you take 4207, write DCR C, which is 0D. Then there is a single byte instruction. Then you take a next instruction, jump on no 0, opcode is C2. Now, you have to check where to move. So, add B is 80. So, this address we have to move 0642. Okay. Now, we have to leave for 3 address 8, 9, 10, that is 0A. Next address is 420B, which is 76. Okay. So, now we will enter this opcode into the kit and we will execute the multiplication of 7 in 5. So, multiplication of 8-bit, that is 7 into 5. Now, execute the program. Start with the 4200, 06, 07, then 0E, next number is 05, then clear the accumulator MVI A comma, that is 3E00, then add B80, then DCRD, then jump or repeat the loop till the carry. So, C2, 0642, store the result at 32 4000, that is 4300, then halt it, reset. So, now go 4200, execute, reset, take the result where 4300. So, 7 into 5 is 35, its corresponding hexadecimal number is 23. Okay? So, we got the answer. Now, we will try to write the multiplication program with carry. With carry means it exceeding the size. 8 cross 8, it may be the resultant value is 8 bit or it may be 16 bit. If it is 16 bit, then how can we write the program? The previous program is not sufficient because the 8 cross 8, the result is stored only in the accumulator, right? So, we have to initialize the one more register to hold the carry or the exceeding bits. So, I have taken the example 78 into 22, right. So, how to multiply 78, 22? So, 2 into 8, 16, 16 is 1 0, right. So, I will enter the 0 here, keep 1 as carry. 7 into 2, 14, 14 plus 1 is 15, 15 is F, right. The same thing again repeated. So, the final answer is 0, F, F, 0, right. So, after adding or after multiplying this program, this F0 is in accumulator, this will be to be carried by the separate register. So, I will use the D register. So, D and accumulator having the 16 bit result, because 8 bit and 8 cross 8 maybe the resultant is 16 bit. Okay. So, now we will check how to write the program. Take B and C register to initialize the value. Say MVI B, 78H. Next MVI C, 22H. Okay. So, now I have to initialize the register D as 00H, which is to hold the carry values or exceeding the bits. Now, I am starting to add MVI A. Before doing the addition, I have to clear the accumulator. So, once accumulator is cleared, now what is the meaning of that? 78 to be added 22 times. So, add B. Add B means 00 plus 78. So, after adding, I have to check whether carry is occurred or not. So, if no carry means what I have to do? Simply decrease the C register and continue the process till it reach the 0, right. Till reach the 0, I have to add and continue the process. If carry is occur, what I have to do? Increase the D register. Increase the D register. Okay. So, add, if any carry is occurred, increase the D, then decrease the counter, then rotate it. If no carry means without increasing the D register, simply decrease the counter and rotate it. Whenever it exceeding the size, that time only the INR D instruction will be executed. So, after executing this, now I will store the result, the sum of the value which is in the accumulator, right. So, I want to move this to L register. Okay. So, the accumulator, the sum of the value is moved to the L register. The carry which is in the D register want to move in the H register. So, now the result is stored in the H and L. So, I will use this instruction SHLD 4300 H. So, it represents the L value will be loaded in 4300, H value will be moved to 4301. So the address automatically increased and store the result. Then terminate the loop. Now convert this program into opcode. So MVIB, I will take the same address 4200. MVIB is 06, then data is 78, then 4202, MVIC which is 0E 22, then 4204, opcode for MVID 16, the operand is 00, then next to address 4206, MVIA 3E 00, then 4208, add B 80, then jump on no carry, right, 4209, jump on no carry is C2, then leave 3 address, later we will enter. So 9, 10, that is A, B. So 420C which is INRD. So after writing add B, now JNC opcode is D2, then leave 2 address. So 9 A, B, now we are in 420C, I have to enter the opcode for INRD. INRD is 14. The next address is 420D. In 0D I have to write DCRC which is 0D. Then I have to write 420E, jump on no 0 which is C2. Now I have to where to switch over, add B which is 80, right. So 08 and 42 I will write. This jump on no carry I have to switch over to decrease DCRC. So the value is 0D 42, right. So after that I have to use a moving instruction, that is 42, this EF 10, then 11. 11 is move L comma A 6F, then 4212 move H comma D 62, then 4213. So SHLD is 22, then 0043, that is 3, 4, 5, then 6, 16 is 76, halt. Okay. This is a conversion of program into opcode. Now we will enter this opcode into the kit and check what is the answer of 78 into 22. 16-bit addition with the carry, that is multiplication of 78 into 22, right. So take the address 4200, type the program 06 78 0E 22 16 00 3E 00 80, then D2 0D 42 14 0D C2 08 42 6F 62 22 00 43 76. So we will check the program again 4200 06 78 0E 22 16 03E 0 80 D2 0D 42 14 0D C2 08 42 6F 62 22 043. Okay. Execute the program. Go 4200. Execute, reset. Now take the resultant at 4300. Next F0 0F. So already we have discussed in the program. So we got the answer. summary, in today's episode, we have discussed how to multiply two 8-bit numbers. After multiplying two 8-bit numbers, the resultant may be 8-bit or 16-bit. Within the 8-bit, how to write the program, and if it is exceeding its size, how to initialize one more register to hold the carry values. So, the 8 cross 8 multiplication with carry and without carry programs were discussed. Questions. The first question, illustrate the instruction SHLD 4500H. That is, while execution, how the address will read and how the data is stored in the register. Second question, how many bytes in MVI D, 00H instruction. Third question is, write the difference between MVI register, 8-bit data and LXI H, 16-bit data. Thank you.